Hey everyone. I thought we could start with bell work. Will you please graph this function? Don't look at me like that. Of course you should be able to do this. All right, I'll go through it, but you're doing the next one. So remember, outside the function, y transformations. Inside the function, opposite land, therefore these are x transformations. What order do I do these in? That's right, PEMDAS order. So I'm going to multiply the y's by 2 and then subtract 4. How about these? Do I do them in the same order? Do I divide the x's by 3 and add 1 to them? No. Do I add 1 and then divide by 3? No. Inside is opposite land. I follow SADMEP and do the opposite of what I see. I subtract 1 from the x's. I multiply the x's by 3. Okay? So let's start off with our reference points, 0, 0. 1, 1, and 4, 2. Now let's carry out these transformations. We've got 2 x transformations and 2 y transformations. I can do an x and a y simultaneously because they don't affect each other. So because I do PEMDAS, this y transformation comes before this, and I do SADMEP on the inside, this x transformation before this. So I'm subtracting 1 from all the x's, and I'm multiplying all the y's by 2. So my transitional points will be negative 1, 0, 0, 2, and 3, 4. Not done yet, need to come back here. This is a horizontal expansion. It's going to pull the graph wider because I'm multiplying all the x's by 3. And then, don't forget this guy over here, subtracting 4 from all the y's. So the points I need to graph are negative 3, negative 4, 0, negative 2, 9, 0. So there's 9, 0, there's 0, negative 2, and there's negative 3, negative 4. Remember, this is a hard stop, no arrow on this side, but we should have an arrow over here. Okay, any questions about that? All right, so let's quickly review, because if you were comfortable with that, you should be comfortable saying f of x plus c. What is this? This is a vertical shift, and we add c to the y's. And then we've got f of x plus c. That's inside the function, so that's a horizontal shift, and we do the opposite of what we see. We subtract c, not from the y's, but from the x's. Okay, next we've got c times f of x, and we know that's a vertical stretch, or compression. It's a stretch for c values bigger than 1. It's a compression for c values between 0 and 1. And what do? We multiply the y's by c. Okay, then we have f of cx. This is a horizontal stretch or compression. But remember, not just that compression has two S's. But remember that inside is opposite land, so we have a stretch going on for C values between 0 and 1, and we have a compression for C values bigger than 1. This is opposite what it was for our vertical stretch or compression. And here, I'm not going to multiply the x's by C, I'm going to divide the x's by C. Okay? So that's all the basics we're supposed to be comfortable with. For those, don't forget the reflection ones as well. Negative f of x, that's reflects over the x-axis. I know that I'm supposed to multiply y's by negative 1. And if I have f of negative x, that reflects across the y-axis. And so I'm going to divide x's by negative 1. Look, I know I'm going across the y-axis. In order to do that, I have to do something to the x's. And then finally, of course, we could have the double f, negative f of negative x, and that's a 180-degree rotation, I think. But we're certainly going to say reflects across both. And so we need to multiply y's by negative 1 and divide x's by negative 1. I know you could just multiply by negative 1 here as well, but look, inside is opposite land, and if you start multiplying, when you see that, you're going to do it at times when you don't want to do that. Okay, great. So we reviewed all our transformations. Now it's your turn. So will you please graph y equals to cube root of 3x plus 4 minus 1. Okay, now remember, start with your reference graphs. You know the shape of this function. Start with the reference graph, start with the reference points, and then apply your transformations. Apply your transformations. You've got 2 x's and 2 y's. Come back when you're done, or when and you want to check your work, or if you're stuck and need some help. So our reference points for cube root of x are negative 1, negative 1, 0, 0, and 1, 1. Now, how do I carry out these transformations? I have 2 y transformations. I follow PEMDAS, so I have to multiply before I subtract. I'll multiply all the y's by 2. And then I've got 2 x transformations. I have to follow SADMAP, so I'm not going to divide by 3 until after I've subtracted 4. Subtract 4 from all the x's. So my transition points are going to be negative 5, negative 2, negative 4, 0, negative 3, 2. Okay, but we have another round of transformations to go. I need to subtract 1 from all the y's. And I need to divide the x's by 3. So my final points then are negative 5/3, negative 3, negative 4/3, negative 1, and negative 1, 1. My recommendation is that you draw this graph. There's no negative here, so it didn't reflect. It's not upside down. We're just going to have this, and we're going to have this. Okay, and so this point is our inflection point, the middle point, negative 4/3, negative 1. Then we've got this point here, negative 1, 1, and this point over here, negative 5/3, negative 3. Okie doke. Now, if you don't like that, how about this? We could do this instead. Let's make a graph where the x's go by thirds. So there's negative 5/3, there's negative 1, and my y's go by ones. Boink, 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 boink. So we've got negative 1, 1. That's here. Don't forget to label the points on the graph, or I'll be marking it wrong. Negative 4/3, negative 1. And negative 5/3, negative 3. And please don't draw this shape. That's the wrong shape through the right points. I would have to mark that wrong. Okay? Instead, draw the proper shape. We'd like this to be vertical right there. Any questions about this? Okay. So, let's do one more. I can well envision that in our live Zoom, I might ask you to present this or give you a bunch of problems where you do one and someone else does another, and then you all have to present yours. Okay, so how about this one? Y equals negative 1/2 absolute x over 4 plus minus this time 5 plus 3/2. Okay, give this one a try. Welcome back. Our reference points, negative 1, 1, 0, 0, 1, 1. Okay, so here I see two y transformations, two x transformations. Going to multiply all the y's by negative 1/2. Going to add 5 to all the x's. So my transition points are 4, negative 1/2, 5, 0, 6, negative 1/2. Next, I'm going to multiply all the x's by 4, and I'm going to add 3/2 to all the y's. So my final points are 16 minus 1/2 plus 3/2 is 2/2 or 1, 20 3/2, and 24 1. Okay, so let's make a graph. Now, I know this is a flipped upside down absolute value. So I'm going to just draw a flipped upside down absolute value. I know this is my middle point, 20 3/2. This point over here is 12 1. And this point over here is 24 1. Okay? Please don't do this. Oh my God. Because you've got to get to 24. Don't do that. Okay. Thinking. That's what we want. Thinking. Okay. So what about this f of x? This is not one of our reference graphs. So we've got 3, 0, 1, 2, negative 1, 2, and negative 5, negative 8. This is f of x. But what I want to do is I want to graph g of x, which happens to be 2f of x plus, no, minus 3. Okay, so how am I supposed to do this? Well, these are my reference points. These are my transformations. I apply these transformations to these reference points. So negative 5, negative 8, negative 1, 2, 1, 2, and 3, 0. So what transformations are we talking about? Well, this is outside of the function, so I know I'm supposed to multiply all the y's by 2. And this is inside the function, so I know I'm supposed to add 3. And so my final points will be -2, -16, 2, 4, 4, 4, 6, 0. And I need to graph that. So there was my shape, -2, -16, 2, 4, 4, 4, and 6, 0. Hey, what would happen to this graph if we had done that? What changes? Well, I'd be multiplying by -2 everywhere. And so this would become -4, this would become -4, this would become +16. So what does that graph look like? Well, that graph, because there's a negative out in front, is a reflection. We start over here at -2, +16, then we go down to 2, -4, we go over to 4, -4, and then we go up, we go up, I guess I can't put that there, 4, -4, and then we go up to 6, 0. Okay? So, let's go back to putting this reference graph here for you. F of x is going to be this picture for the next few problems. We've got this point here at -5, -8, and this one here at -1, 2, and this one here at 1, 2, and this one at 3, 0. Okay, there's our f of x, and would you please graph g of x, which is 1/2 f of 3x plus 1 minus 5/2. Okay. Give that a try. Don't forget to start with the reference points and using the transformations. So, our reference points, -5, -8, -1, 2, 1, 2, 3, 0. We've got 2 x transformations to apply and 2 y transformations to apply. Remember, SADMAP on the x's means I'm going to subtract 1 from all the x's, but PEMDAS on the y's means I need to multiply all the y's by 1/2 first. So our transitional points will be -6, -4, -2, 1, 0, 1, 2, 0. And then I'm going to come back and I'm going to do dividing all the x's by 3. And I have to subtract 5/2 from all the y's. So my graph then, oops, I should probably write out these final points. -2, that's 8/2, 3/2 is -11/2, -2/3, -3/2, 0, -3/2, and 2/3, -5/2. Okay. So -2, -11/2, -2/3, -3/2, 0, negative 3/2. So I guess that's there and there for those of you who like axes. And then this point over here is 2/3 negative 5/2. Okie doke. Should be pretty comfortable with this. Let's do one more. We'll work with the same reference points. Or better yet, let's change it. Let's make f of x now be this. So negative 2, 4, 1, negative 1, 3, 1, and 6, negative 4. So there's f of x, and I'd like you to graph g of x, which is negative 4 f of 5 minus x plus 2. Now, be careful in here. I might actually recommend that you rewrite this as negative 4 f of negative x plus 5. That you use the commutative property of addition that your middle school math teacher tried to get you to see so that you could use it now rather than get stuck here. This is subtract 5 from the x's and then divide the x's by negative 1. So if I start with my points, negative 2, 4, 1, negative 1, 3, 1, and 6, negative 4, I know that I'm supposed to multiply all the y's by negative 4, and I'm supposed to subtract 5 from all the x's. So my transition points will be negative 7, negative 16, negative 4, 4, negative 2, negative 4, 1, positive 16. But we're not done. We still need to divide the x's by negative 1. And we need to add 2 to all the y's. So the points that I'm going to graph are going to be 7, negative 14, 4, 6, 2, negative 2, and negative 1, 18. Okay? And when I think about this reflected across the x-axis, this reflected across the y-axis. So we're starting over here with 7, 14. So here's 7, 14. Now I know this one is 4, 6. So 4, 6 is to the left and lower than. And then I've got 2, negative 2. So 2, negative 2. And negative 1, 18. I feel like there's something wrong here. I want to go back and check because I don't remember that shape. I remember a shape that went like that. That, yeah. What did I do? I had negative divided by negative, that's positive. I have positive 4 plus 2 is 6, so I like that point. And here, negative 7 divided by negative 1. Negative 16 plus 2 is negative 14. Oh, you silly goose. Negative 14. It's down here. 7, negative 14. Okay, so there's our graph. Any questions? Well, let me know if you need help or more practice on these. I can certainly give it to you. Next, I'd like to talk about our dear friend y squared. You know, y squared comes up a bunch, And I mentioned this in the last video, that x equals y squared should probably be one of your reference graphs. It's not a function, it's a relation. It fails the vertical line test. It's positive square root of x and negative square root of x. It passes through 1, 1, passes through 1, negative 1, and it passes through 0, 0. That's our reference graph. But we need to be able to graph variations on that. So, what about x equals negative y squared? So, yeah, about that. What I have to do here is draw this. Now you might be thinking, hey, I need to multiply all my y's by negative 1, but that's not what I did. I multiplied the x's by negative 1. How come? Well, if we solve this equation for y equals so it's in function form, I'd start by dividing both sides by negative 1 and then taking the square root. And so I'd have plus and minus square root of negative x. C, dividing the x's by negative 1, reflecting the graph over the y-axis. That's what this is. It's a reflection of that one. And it's not a reflection across the x-axis, it's a reflection across the y-axis. Now, I don't particularly want to take the time to solve this for y equals. I just want to be able to look at that and say, okay, this is a reflection this way of my good old y squared graph. Okay? So then what about x equals y squared minus 1? Well, this is taking that y squared graph, and our brains say shifting it down 1. But really, we're only shifting down 1 if you're looking at the graph this way. We went down 1 that way. And in which case, sure, you can think about this that way. It's fine. So here we have negative 1, 0. Here we have 0, 1. Here we have 0, negative 1. Okay? I shifted the graph down 1. And that might make sense, you know, if you go to all the trouble of doing this and then this. Don't forget the plus and minus. You know, square root of x plus 1 is square root of x graph, this, shifted left 1. And negative square root of x plus 1 is flipping that over. And so that's why we have this shape. Okay, so why don't you do this one? X equals y squared plus 3. Please graph that one. Okay, welcome back. So if this one shifted down 1, this one has to shift up 3. So we've got 3, 0. We've got 4, 1. We've got 4, negative 1. And there's our graph. All right. Let's do a couple more of these. How about x equals 2 minus y squared? You know, that middle school teacher who was trying to teach you the commutative property of addition would like to know that you recognize that that's the same as this. I'm flipping it upside down, and I'm shifting it up 2 places. So we've got 1, 1, we've got 2, 0, we have 1, negative 1. And there's our graph, right? Reflected it, so I'm taking this graph, and I'm reflecting it to make this graph, and then I'm taking this green graph and shifting it 2 places up. And remember, I'm looking this way to say up. Okay. Hey, I know. Let's do some real fun ones. Because actually, you have to do these in Chapter 7. How about x equals y squared minus 5y plus 6. So I know that this is y minus 2 and y minus 3. And so I know y equals 2 and y equals 3. So 0, 2, 0, 3. And I don't see a negative in front here, so it should look like that positive y squared. And so I draw the parabola through those points. Remember, halfway between these intercepts is going to be this vertex. So I know the y value there will be 2.5 or 5/2. I don't know what the x value is. And if I want to find out that x value, I'm going to have to take this y value and plug it in. So if I plug in 5/2 here, 5/2 minus 4/2 is 1/2. 5/2 minus 6/2 is negative 1/2. And so I get negative 1/4 as my x value. Okay? Wasn't that fun? Now here's yours. Will you graph x equals y squared plus 5x minus 6? Okay. Come back when you're done, or if you need to check and you have questions. So I know that this factors, no wonder you're back. That's got to be a y. Sorry for the typo, everyone. Okay, come back now when you're done. Excellent. So y plus 6, y minus 1. I've got y-intercepts at negative 6 and at positive 1. And so my graph looks like this. I know there's a vertex halfway between these, so that's going to be negative 5/2 for the y value, because halfway between negative 6 is going to be negative 5/2. And then I need to find the x value there. So I take this y value and I plug it into these places. Negative 5/2 plus 12/2 is 7/2. And negative 5/2 minus 2/2 is minus 7/2. And so I get negative 49/4 there. Okie doke. Now, I will tell you that when we get to chapter 7, we're going to be doing things like this, and we're going to be finding the area in between those two curves. I know, and so that's going to be mind-blowing enough. I better be comfortable being able to graph these things so that when I get there, I'm all comfortable with it, okay? All right, so that's a quick review of transformations and of things we need to be comfortable graphing with. That was assignment 9. I notice we have a worksheet. You can find this worksheet in our Office 365 team. Remember, you go into our Office 365 team, and on the left-hand side of the screen, you'll see the channels like General and Assignments and Daily Notes. And if you click on Assignments and then go up here and see Files, and then click on Files, you'll see folders show up for each of our chapters. You want the one that says Chapter 1. Inside that Chapter 1 folder will be all these worksheets as well as the assignment calendar. Alrighty. I hope this was useful, and I'll see you in the next video. Take care, everyone. Stay safe.